Very good and welcome. This is Dramani Online Maths. Please, today we are going to look at D'Alembert. For the D'Alembert, it falls under the wave equation, okay? D'Alembert is used for wave equation, so you should take note of that. For the D'Alembert, let's assume that we have something like this. UTT equals C squared UXX, okay? Then U of x comma 0 is given as, let's say, f at x, then u of t x comma 0 is given as, let me use different letter, let's say j at x. Okay, you realize that this one has been differentiated and this one is not differentiated, so this is what we call the initial displacements. And this is what we call initial velocity. We all know that anytime we differentiate displacement, we get velocity. So you should take note of this. Now, for the D'Alembert, it has a formula. Okay. And the formula that we use is given as u of xt equals f at x plus ct plus f at x minus ct. All this is divided by 2 plus 1 over 2c, the integral of x minus ct, x plus ct, then j of s ds. Now let's try to understand this formula. It's not anything difficult, okay, depending how you see it. Now with this formula, because this thing is associated with waves, we call this one backwards waves. Backward wave. And this is forward wave. Is that okay? The C here is the wave length here, okay? The C here is the same thing here. So that one, if let's say the coefficient of UXX is 2, it means that C is 2. Don't take square root of anything. Is that okay? Just C is 2. When it is 4, C is 4. All right. Now, let's also look at this one. J at S. Now, for this J at S, because we are integrating, then you'll be looking at the initial velocity. So when a question is given to you, whatever that is given at the initial velocity is what you are going to, whatever function that is given, is what you are going to integrate. So if it is 0, you integrate 0. If it is x squared, you integrate x squared. Is that okay? If it is cos, you integrate cos. So that is it. For this ones, f at x plus ct and f at x minus ct, that's the backward and the forward wave, is always taken from the initial displacement. So you should take note, the initial displacement is used at this place, then the initial velocity is used at this place. Okay, so these are the things that you should know about D'Alembert formula. All right, so let's try our hands on this one. Solve using the D'Alembert formula culture problem. So this is the equation that is given. You see, this is a wave equation. Is that okay? Here, C is still C because it has been maintained. Now, U at x comma 0 equals f at x equals a sine x. It means that with the formula that I stated, this side is the initial displacement and the u subscript t is the initial what? Velocity. Now, let's look at something here. With this, because we are using the formula, we know that the formula is having forward and backward. So let's write, let's say the backward, which is x plus ct. Now here, what is happening here is that this backward is associated with this, the initial displacement. And for the initial displacement, f of x is associated with the f at x plus ct. But in this case, f of x is given as a sine x. So in place of x here, that is what we have, x plus ct. So we are only going to replace this x by x plus ct. So wherever we see x here, we just replace it by x plus ct. So here I'm going to have a sine x plus ct, right? Then we also move to x minus ct. And this is going to give us a sine x minus ct. Is that okay? Also, from the formula, you also get to know this x minus ct. We are looking at the integration sign, x plus ct, which is j at s ds. Okay. Someone might ask, why am I not bringing the x, but I'm using s? You can also use that one, but you see, already here is xx, so you can replace by different variable. Now you know that this one, which is x minus ct of x plus ct. Now this js, which is jx here, because I'm saying they are the same, just that because they are the limits are just xx, I'm just replacing by different variable. This j at x here is given as what? 0. It means that js is 0. So the whole of this place will be 0 ds. When we integrate 0, we get 0. So here the answer becomes what? 0. So it tells us that the final answer here becomes u equals. So let me write the formula. The formula is f at what? X plus ct plus f plus x minus ct all divided by 2 plus 1 over 2c integral of x minus ct x plus ct j of s ds. Okay, so this is the formula. So I'm going to have u equals, this side automatically everything there goes to 0 because we had 0 here. So the next thing that we have is f at x plus ct. We had this one, which is a sine x plus ct plus a sine x minus ct, and the whole of this is dividing by what? 2. Is that okay? So here what you have left is to expand this. So let's expand a sine x plus ct. If we expand this, you know the expansion of this, that will be a sine x cos ct. You maintain the plus. Then you have a cos x sine ct. Then we also expand this one, which is a sine x minus ct. So that one you are going to have a sine x cos ct minus a cos x sine ct. So this is the two expansion. You realize that the negative one here, negative a cos x sine ct, then positive a cos x sine ct are the same. So this one will cancel with this. So my final answer, let me write it here, will be equals to this one and that. So they are also the same. When you add this, it will give you 2, and 2 divided by 2 will give you 1. So our final answer becomes a sine x cos ct, and that becomes the final answer. Thank you very much for watching. Let's move to the next example. Okay, so now let's look at the second example. The same lesson preamble. You have to use the D'Alembert. UTT equals c squared uxx. Everything has been given. The initial displacement, initial velocity. Okay, so first let's find the forward one, f at x plus c solution. X plus ct will be, because here c is still c, nothing has changed. F at x plus ct will be equals to a e. Now for this case, look at what they said. They said that u is equal to f at x, and f at x is equals to a e to the power negative x squared sine x. So what is happening here is that here the x, this x, like I explained to you earlier, is just going to be like x plus ct. So instead of x, we replace by x plus ct. So wherever I see x here, I will replace by x plus ct. Simple as that. So here is going to be negative bracket open x plus ct sine x plus ct. That is the backward. So we also move to the forward. So this one, we are going to have a e to the power negative x plus ct sine. So I think here will be negative x minus ct. So this is what I have for the two. Okay. Also, looking at this one, it tells us that when we do the integration side, we get 0 because that one is given as 0. So we are good to go. So the integration side is 0. So what I'm going to do is I'm going to add these two together. So with this, I have my u to be equals to, you know the formula, how it look like. F at x plus ct plus f at x minus ct, and this 2 is for what? The initial displacement, plus 1 over 2c, the integral for x minus ct to x plus ct, j at s ds. So if you look at this one, this is for the initial velocity side, but for the initial velocity is 0. So if I even integrate 0, I'll get 0. So everything there goes to 0. So what is left for me is to add this to this. Is that okay? So that is very simple to do. If you want to add this to that, you just add them, then you divide it by what? 2, and then your answer is ready. That is all. If you feel like doing some simplification, you can do it. Thank you very much for watching. I will move to another one, but that one will be in next video. Thank you very much.